us on this Elektor television, Elektor.tv webcast. For your information, we've moved our entire studio from our normal place to this place, and that has been a hell of an effort. Thanks to everybody. For today's is a rather special occasion, very special I think, because we have Benedict Sauter presenting on his Linux project. My name is Buiting. I am the editor of Elektor magazine. The Embedded Linux project was first published in Elektor magazine in, was it correct, Benedict, in the May issue 2012. It has covered like 80 pages, I think, in the magazine, with a huge success and a huge response. The project is not finished yet. That's what we like. We like projects to go on, to continue with the audience, with you, with your developing skills and everybody helping out. Right, Benedict, and welcome, and thanks for being with us today.
Nice to be here.
Perhaps you can tell just a few words on your background as a designer and how you came about doing Linux instead of Windows, perhaps.
Ooh, yes. I started to work with PCs when I was very young, about 12. I started with this C64.
Commodore 64?
Yes. And then I have played some around, some basic I write, and then I stopped to work with the PC, and found back to the PC, and I was about 16.
Yeah.
And then I have a friend, he worked with Linux, and then I found directly into the Linux system. Yeah. This was my things. And I'm a computer scientist.
Okay.
I studied, not electrician, I come from the operating system side.
Okay.
You understand?
So big programming systems for...
Yes. And then during my university life, I get in touch with microcontrollers. And I love microcontrollers, 8-bit and controls, build small things. We built an USB programmer together with Elektor. And then I learned, or I see, wow, it's no possibility to have run a Linux system on a microcontroller.
Okay.
And that's the reason why we're now here with the Linux board.
So, did you also at some time program Linux on a PC? I understand that correctly.
Yes.
And then you thought, why don't I do this on a microcontroller?
Yes, I also developed drivers on the PC, developed server applications, web-based applications, work with databases and things. And if you know, when I was 16, about a computer like a 200 megahertz per PC was normal.
I remember those days, yeah.
For me. And now we are here with the same speed
on an embedded board.
Yes. And that's
I'd like to address the audience for a second. If you have any questions on embedded Linux today, please stay where you are and ask the questions when we are finished with the presentation. I can guarantee you, all of you here, that this is an extreme specialist, Benedict. I've known him as a writer. I'm an editor myself, and his stuff is really first class and of an extremely high level. Okay, Benedict, I think you have a presentation ready for us.
Yes, we have some slides.
And we will do this chatting along cheerfully.
Okay.
And we will look forward to seeing what this board is and what it can do.
Yes.
So go ahead.
Okay, go ahead. On the first slide, we see the nice Elektor Linux board.
With the penguin.
Yes, it's important things.
Yes.
I told, Elektor typically comes from the microcontroller. That normally he likes compilers. He have not so much RAM. He have C, and he have some LEDs and buttons. And now we come from the second side. That we come from the Linux. We come from operating systems. We come people who have a mouse, who have a keyboard and something like this to work with the PC.
That might be confusing to begin initially. Okay.
This is our vision. That we now comes from the microcontroller, but we will use it like a PC, but we will use it as microcontroller.
Yes. Okay.
This was the first thing. You were always told that we started in the May last year, and the idea was not to bring out the Linux board for your readers here and work with it. No, yes, we have the idea that we told the people all things behind.
Yes,
you have to know.
Yes, we are Elektor magazine.
Yeah.
We explain things, how it works.
Yes. so this is why the board is very easy. We remove all things we don't need.
Okay.
We use a really easy processor, an easy ARM9 core. We use an easy RAM controller. And as disk storage, we use an SD card. That's all what we need. These three components to have run a Linux system. This was the idea. You don't need a programmer. Normally you need JTAG debuggers and ISP interface and something. You don't need. You have a cheap SD card. You can put it into your PC, copy the firmware and something like this on
put
this
it
card.
back and get it going.
Yes.
Yeah.
This
so that's your media transport device, that SD card.
This is the storage also for the program, for the operating system, all these things. Right. But this is normal for embedded system at this time. The idea was, now the next step, always you talk about Linux. Oh, Linux, yes, Linux. But what is Linux? You have to understand the components behind Linux. You have to know what's the bootloader. On the BIOS, on the PC you know the BIOS.
And keep them separated.
Yes, you have to know this is a bootloader. Linux is only the kernel. It's only the main firmware. And then you have a very huge file system where are many different programs and libraries inside. And normally you call it Linux, but Linux is more. It's a bootloader, it's a kernel, it's the device, it is the operating system, all these things, the tools you need to have to run. So we started with the readers to explain the different components, the tool chain, from where are, historical, when they started, and which universities they started, which people are behind this, so they have here.
That's a good background to start. Yeah,
this was the idea, and then we installed the tool chain together. Then you know what you installed, who was the author of the tool chain, and then we compiled the kernel. You know, the kernel is from Linus Torvalds.
Did you test all this, Benedict, prior to the publication, to part 1, all the software? Or did you gradually develop it along the way?
No, we all work together with the things. We test it, we build it together, then we see directly the results, if it happens, if it's good or are there errors, and you have directly a feedback for these things. And this was the idea that we have enough time. Now we are at the moment at issue 6, I think.
November.
Of the series.
Yes.
And now we can go deeper and deeper, and now the next step is that we have a platform for applications. Now we have all things together, what a normally microcontroller developer needs. He has a firmware, he has a console, he has drivers, and now the idea is what can we do? We will build amazing devices, applications, something like this. Perhaps many people ask us why we do have a network plug here.
Why do you have network plug there, Benedict?
And we say there are so much interesting applications they don't need a network plug.
Okay.
Because if you build a clock, perhaps, you don't need an application.
No.
What should be there?
Get rid of it.
Thing. And then there are many things, a bicycle, a computer for a bicycle, perhaps. Okay. And then you don't need always this huge network plug. But you can also put a network plug additional to this. We use USB as a system, as an interface for many things. There are also many USB LAN adapters and something like this, so that you can put network over USB, something like this, because we are coming from microcontroller.
Okay.
And normally we haven't got this.
Stepper motor.
Yes,
I have something here
already. Which we will use next articles, for example, a stepper motor. We have a connector here, it's a fits and pole connector, and now you can easily build own boards so you can connect a stepper motor. In the next articles are descriptions how you can control a stepper motor over Linux. That you can.
Do you need a lot of external hardware, Benedict? It doesn't look like much now, does it?
No, you need the motor.
A few ridiculous components and a few wires.
Yes, and the controller of the motor.
So all the intelligence and the driving is vested in the Linux board.
Yes, additionally there's a motor driver.
It's motor driver,
under this PCB.
Of course. Yeah.
But then you can directly control a motor. And it's very easy. You can use your own language. You can say, oh, it's for me interesting to bring programming in C. Or you say, no, for me it's Bash, nice. Or there are many nice, interesting programming languages like Lua, Perl, Python, and something like this.
So you're going to explain to the readers how exactly to do that, and not just present an end product as many companies here, with all due respect do.
No.
We delve into the technology, we explain how it works, and we offer all the open ends to our readers, the Elektor audience, to know how it actually works.
Yeah. And we do directly some demos, so that you can really see how it works, and you can build on move the motor on something like this.
What is it? A micro stepping? I'm very curious, Benedict. You know,
Yes.
but I always want to know what's the smallest step size?
It's 1/60. Also,
1/64th.
yes.
Yes. Okay.
But there are many different motors. Also, first we have a motor then. With a motor you can build many interesting applications. Perhaps you have some in your mind?
Yes, I do.
Okay.
I do, for some mechanical applications. That's why I was asking. Yeah.
Perhaps you can automate your coffee machine?
Yes,
that is
that would be very nice. Yes.
something like this. Okay, the next thing is you always a microcontroller board needs a display.
Yeah,
Every
sure. Everybody
developer
wants displays.
yes will show something. Hello Jan, how are you?
How are you today?
Every day you use this device.
Is your coffee ready yet?
Yes. Or send some messages to your wife or something like this. Please bring my coffee.
Yeah, please bring my coffee. Thank you, dear.
That's why we built a display board. There are different display boards, easy character displays, or displays where you can paint
Graphics.
yes, and menus and something like this. We also wrote some small command line tools and some libraries that you see or have here some examples you can use, build your own display application and something like this. So now we have...
It's controlled over SPI.
Yes.
So that's very, very flexible.
Yes.
That gives you a lot of power.
Yes, all typical microcontroller interfaces we have got here.
Sure.
That's important. SPI, E2C, GPIO, ADC,
Okay.
PWM, something like this. Now we have two things and now we can build better applications.
Okay.
Perhaps you have something all this.
Yeah, I'm always thinking in the back of my mind for applications.
Okay. Have a look at the next. Okay,
More
the next.
eye-opens. We want more eye-opens, Benedict.
Yeah.
Please.
That's normally you have to need I/Os for all things.
Yes,
to
sure.
control buttons, to control LEDs.
Input as well as output.
Yes, and we use I/O expander with E2C interfaces, and then you can bring to this board 7 of these I/O expander. That means you have 7 about 120 I/Os. It's very enough.
All individually addressable.
Yeah. And it's important for us as a microcontroller developer as we have many with a motor, a display, and many I/Os, digital, and something like this. And this is what we firstly show here on this thread is for January. That we integrated all these things into our extension kit. That we have a common base platform for the readers or for the people who want to work with this board. That you have a display, you have a buzzer, so that you can give an
audible feedback.
Yes, feedback. You have some buttons that you can control a menu, and also the I/O expander is down underneath.
Yeah, okay. So
and we have a clock.
Okay, real-time clock. Real-time clock.
It's very
with
important
the calendar.
that the coffee starts at 6.
Okay, coffee should start at 6
randomly.
And if not, big error.
Or you have cold coffee.
Cold coffee.
And also the same connector we put here on this.
Straight to the board,
yes.
And everything's done.
Yeah. You can also build your own connector with more.
Sure.
Between, then you can connect motors and something like this.
Is it also possible, Benedict, to have more of these expansion boards even on the same cable, or is that not a good idea?
It can, because we use E2C for the main things, and you can here plug your addresses and something like this, so that you can configure these things like this. And
3D printer.
Yeah, this is what we have in mind.
That's what we must have. Yeah.
Perhaps you see all these methods. With Elektor, we planned to. This is a version of a 3D printer from the Elektor lab.
Yep, I recognized it. Yep.
Yeah. We take it, and now we are planned to pimp it up with all these nice things. Yeah. That we have a Linux-controlled 3D printer with all these very interesting things we have, like network, like USB connectors. We can directly calculate images here on this, or complete cases or housings. We have enough power. We can build a web graphical interface.
Okay.
On the last issue, we showed the people how they can build their own web-based application.
Yes, that is in the December issue, I think. Correct? Or is it? No,
yes.
It is in the November issue.
Yeah, that's
here.
It's
the web server, do-it-yourself style.
Yes.
Yeah.
Where we build a small button that we control the LED. It's not very interesting, but it shows the reader how it works.
Okay.
In the next version, I think we show the people how you can use with a typical phone, something like this, so that you can lie in your living room and say, oh, coffee.
Coffee, please. Dim the lights, please. Yep. I have to go to bed. Yep.
And these components are very interesting for the 3D printer.
Okay.
That we have a user interface, web-based user interface, a display directly on the board.
So this thing is really internet ready in any way you like.
Yeah,
it's just waiting to be on the web and controlled from Augsburg or Munich or wherever you are.
Or from Limburg directly.
Or from Limburg, from Castle Limburg to Augsburg.
Print directly. Yeah. Very interesting.
Distance doesn't exist anymore now, does it, Benedict?
No.
No. Certainly not with Linux. Thank you. Okay. Eagle. Aha.
It is an open source project.
Yes.
Also, the layout of the board is open source. It's very interesting. This is an easy 2-layer board. You know it?
Yeah. It's cheap, easy to make.
It's very interesting, but this is a BGR. Though it's escaping is not. It's very interesting to study it. But now you can take the files and build your own board. That's not very difficult because we described how it works, the schematic, and then you can say, oh, this board is interesting, but now I have an idea it must be yellow and must be with...
So you're saying to the audience, go ahead, do your own Eagle design, extend it any way you like, and make your own board.
Yes.
That is the true open source spirit, I think.
This is the idea. And then you can publish also your project. On Elektor, we have the new Elektor Labs website where you can publish your own project, show, hey people, there are interesting ideas. I found some TuxPad to play music and something like this, where people try to build own application, they discuss about this, can change, and it's very interesting because you are free to develop your own board and something like this. And one interesting thing I found in the internet was this. This is a case for
the board.
The Elektor board, yes.
Also made with a plastic reproduction machine. Yes.
With a 3D printer.
3D printer.
It comes from the open source community. Some says, oh, it's very interesting to have a case for this, and then they painted this and published it.
And that is also open source everything, Benedict, isn't it?
Yes.
Files and how people can do that. And I think it's in the January 2013 issue, you're going to do a roundup of questions and feedback, aren't you?
Yes.
Because we have a hell of a lot of feedback on the project, on our forums, through emails and so on. Yeah. And I understand you are going to coordinate that and put that in the magazine so everybody can read what's happening in the community. Is that correct?
That's correct. It's very interesting because this Linux, I told I'm a computer scientist, you are an engineer. There are so many different peoples and I have so many different interests. Now in the last issue we start a question or quote that the people can say us, oh, please tell more about Linux Inside. Or please tell more about how I can build a graphical programming. And that is so that we find what the readers will learn, what are their interests, so that we in the next issue can present it.
As Elektor, we are always very pleased to have that sort of feedback.
Yeah,
we are.
And we get many
and that belongs to the open source community and the open source spirit very, very much. To have criticisms, to have improvements, to have feedback. So it looks like a very promising project. Right from the start, Benedict, we were surprised at Elektor about the hell of feedback it generated. And I can congratulate you now because I just got an email just before this presentation that we have reached the 1,500 piece sales level for your board, which is really amazing.
Okay.
When we started out, we thought, well, a few enthusiasts here and there across the globe, but you're now past the 1,500 pieces sales. So congratulations on that. Yes. Okay. I would like to interrupt now and go to the audience, please. If there are any questions you would like to ask Benedict or myself on the project.
My name is Michael Blank.
Michael, okay.
I'm coming from Stuttgart, and I would like to ask, how do you see this product in comparison to the Raspberry Pi?
How
does it compare to the Raspberry Pi in your view?
This is a very typical question we get many meetings. I don't have a Raspberry Pi here, but we come from the microcontroller. We are typical from AVR, 8-bit and something like this. We see it like a very small, less power And these boards only need a half a watt, 100 milliamperes. The Raspberry Pi is more for multimedia. You have an interface for monitor and something like this.
HDMI and even.
Yes, a very strong, much more power than this. But for typical microcontroller applications, you don't need this power. You don't need this very, it's like we call it in German.
Overkill.
Yes, Kanonen auf Spatzen.
Kanonen auf Spatzen. Thank you.
We call it, and this is the main difference.
Yeah, okay. Thank you. I'll ask, are there any further questions? Please go ahead. Please, everybody, feel free to ask. This is open source stuff, and we are open source, as you may have noticed, very much. Please, go ahead.
Well, one thing I was always wondering about was where's the connection between the normal ARM architecture and the Apex bootloader, for example? Where is the step from the normal bootloading ARM architecture to the Apex and then going on with root file system and so on?
Where is the connection between the ARM and the bootloader?
Yeah.
Exactly. How is it implemented?
The bootloader,
Yeah.
as we use as bootloader and Apex. This is really a small bootloader. The bootloader, it's if you connect the power, then the bootloader comes from the SD card. It is copied automatically into the internal SRAM, and then the internal SRAM, the bootloader starts in the internal SRAM, and then firstly we have to initialize the SDRAM. And then we have to copy the kernel from the SD card into the SDRAM.
From the ARM controller itself, does he know about where is the step which knows that he has to start the bootloader from the SD card?
This is normally in an ARM processor. On the PC you have got a BIOS.
Yeah.
Then you know the first 512 bytes are the code that you get and execute. With ARM controllers, you have normally a ROM inside. You can imagine it as a BIOS, and the ROM, the code in the ROM is can be tried to boot from the SD card, can try from a USB, can try to boot from UART. We have here some jumpers where you can control the boot order, like you have on a PC.
Okay.
And this is the first thing in the ARM core that gets the bootloader inside as well.
Yeah, normally I think it's called flexible in-system programming or something like that.
So yeah.
Thank you.
Thank you. Come on, people. Ask your question, please.
Hello, good morning. I'm just interested in the expansion board, and I wanted to know if it's available from Elektor and what time it will be available.
That is a good question, Benedict.
At what time?
At what time?
The expansion board.
I'm afraid I can't put that in an exact time frame yet. It will be
January,
February. In any case, Q1 2013, guaranteed in any case. It will be available. Yes, absolutely. We are supporting this project in any way we can. We are very pleased with it, with the response. So we are continuing the positive response. Okay, thank you.
I have another question concerning the open source nature of the system. Do you think it will be possible for a hobbyist to manufacture such a board with this type of CPU? You said it was open source, but somehow I'm not sure whether you can really build a board with such a package.
Okay, Benedict. The question is, it is an open source project in software terms, etc. And we've got the Eagle PCB layouts. But then the question is, how do people, if it's really open source, can they solder it themselves? The controller.
Yeah.
I think the answer is no, and you shouldn't bother, because we've done it for you. We've done it for you, free of charge, compliments of Elektor. You can do it, of course. I do it like so. But in general, we manufacture these boards ready soldered for you. With maybe Benedict, I don't know, perhaps a few components hand soldered.
But it's also be possible as hobbyists to solder something like this
Oh yes,
by yourself.
with a reflow of
Yeah, this is very. You can go into the kitchen. The first steps I try to solder as
remove the pizza
and put the chip into the oven.
Yeah. So, any more questions from the audience, please? Yeah. Okay, go ahead, please. This is open source, please.
I was wondering which bootloader do you recommend to work with? I mean, between Apex and U-Boot, and above all about an SPI interface. That's my question.
Yeah. Which bootloader do you recommend, Benedict?
Yes, okay. Yeah. The main or in the past the best well-known was U-Boot. U-Boot is very exciting. There are many boards that supported U-Boot and something like this. But we find with this processor, found Apex. And this is a really small bootloader. It's also an open platform that you can build plugins, driver modules for USB, for different processors. But it's not so big because we have only about 100 kilobytes inside SRAM, and the bootloader must fit into this RAM.
That's a good challenge to keep that as small as possible.
Yes.
Yeah. And as fast as possible.
Yeah.
Even to work with an SPI interface, so it's a good election, a good choice. I mean, for an SPI interface, so it's a good choice.
Yes, the SD card at the first step. The SD card is interface is SPI.
Okay.
The first bootloader we copied via SPI to the internal SRAM, and then we switched to an SDRC interface.
Okay. Thank you very much.
Okay, thank you for your questions. Thank you, everybody, for joining us and being with us. It's been an immense pleasure to have you around. It was a great show, I think. We've seen some things we didn't know at Elektor even, Benedict. That is great. We'll always like to hear that. We would like to thank the people of Element 14 here at the stand for hosting us, for having us around on their brilliant stand here in Munich at the Electronica 2012 show. We also thank everybody at the other side of all the LCD screens. So the people watching this webcast, they are all behind their Linux systems, hopefully, Benedict, watching as well. And Elektor, in closing, is very proud to have been able to publish this series together with Benedict. And as I've said, it's completely taken us over in terms of success. And finally, I would like to say, stay tuned to elector.tv. Thank you very much, everybody. Danke sehr. Und auf Wiedersehen in Munich oder Nürnberg. Macht Spaß. Danke.